Williams flash. Looks like it has a System 4 style CPU board. It doesn't work. It doesn't look like there's socket issues though. I think somebody's replaced these two sockets. And these do not look like scan Bs. CPU board has a scan B, a 40-pin scan B, but the rest of these are RNs. I replaced these all with new EEPROMs. The original chips, I don't know, I don't trust them. And plus, this one chip gets rid of this, this, and this. So that's good. Place the socket. All the other sockets seem to be okay. Somebody already did these. You can see on the back, when they did them, they didn't do a great job. Well, they did an okay job, but they had to run a jumper. Got that, cut the battery off. The battery holder was foobarred, as they say. And on the driver board, the 40-pin interconnect gets replaced. And then on all the boards, resoldered all the headers, because they all have concentric circles around the male pins, indicating that they're crack solder joints. So you got to do all these, and then over here for the switch matrix. So the way I like to test this is, first I pull the solenoid fuse, just get that out. I have just the CPU board installed with the power connector, this one right here. And then we're going to power on and watch the LEDs. They should go on, off, and then stay on for a good board. On, off. Come on, baby. There's an exception to this on, off, on rule, and that is with Flash. Flash came out originally as a System 4 game. The software was available both in System 4 yellow ROM, flipper ROMs, and green flipper ROMs, System 6. So it was the first System 6 game, and the on-off on rule does not apply to Flash. It only applies really consistently to the System 6 games. So the fact that the LED is on, the hardware turns it on, the software turns it off, means that it's probably running. But I really don't know without hooking up the driver board, so we're going to use Leon's test ROM just to check this board out. So what I did is I put in IC17, I put in Leon's test ROM, and you can see it's running. So the indication the board was running is when I turn it on, the LEDs go off, because this CPU has to be running code to turn the LEDs off on power on. So now we got Leon's thing in, it is running. Well, I'm using a logic probe. Usually you use an LED with connected to 5 volt, but I can do this. Testing pins 2 through 17 on the PIA. We should get alternating tones. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 2 through 17 I'm getting a pulse. Now there's some other pins I got to check too. In addition, we got to do pin 19. That's pulsing, and pin 39, which is over here. So those are good. And we should probably look at 26 through 33, the data lines. We got to use the logic probe for that. And then pin 34 reset should be high. Pin 34, so let's go 40, 39, 38, 37, 36, 35, 34. And it is high, so that's good. And then pins 26 through 33. So that's going to be 21, 22, 23, 24, 25, 26. Yep, that's dancing. 27, 28, 29, 30, 31, 32, 33. So I've got, on my logic probe, I could see high and low on the arrows there. So the only thing left to do is to test the memory. Now that everything related to the PIA seems to be working, it's time to test the RAM. And you use this here, and what we'll do is we'll press this button. These should go out, then the top one should go on, go out, bottom one should go on, go out, and then it should resume this, you know, blinking on and off if all the RAM is good. So let's give it a whirl. Okay, they're both out. Top on, bottom on, dancing. So what that tells us is that the 5101 is good and the 26810s are good. So actually, according to Leon's ROM, this board checks out good. Got the board installed, put the regular ROMs back in. I have the driver board installed, but only the bottom power connector. All the other connectors are off. All the CPU connectors are installed. Power on, and look, it's booting into the diagnostic mode. So it looks like the board is working. If I do a quick coin door open, power on, power off. Yeah, look, now I got high scores going. So it looks like we got a running board. I can connect all the other connectors back up. Alright, remote battery holder. Let's check the voltages here. 4.5, 4.5. There should be a voltage drop across this little diode up here. See this diode? So I get 4.5 on this side and 4.3 on this side. That's the voltage drop. And then to the last pin of the 5101, we should get 4.3. And there we go. Perfect. So, battery holder in. Take this thing out. We can power up. We should get that. Turn it off. Coin door open. And it goes into a track mode. Perfect. Lights are going. Okay, one other thing to tackle. Look, bottom segment's missing on these displays. And what usually happens is there's 10K ohm resistors here and a set over here. And you get ones that burn. Like if you look at this one here, it just looks fried. So I'll measure them with the ohm meter, but it's probably that one. Probably replacing that will fix this. If I measure this outside 10K resistor, if I can do this one-handed, which is actually a lot harder than it appears, you can see it's open. Compare that to, like, say this one on the end. Man, this is tough to do with one hand. And see how I get 10K. So that's what we need. I'm sure if I replace that resistor, it'll probably fix the problem down here. New resistor installed, and now you can see we got our segments back on those two score displays. So the score displays are all going, and we're good to go. We got ourselves a working flash.